In this video, I want to define and discuss percentiles. Let's let x be a continuous random variable with CDF given by capital F and alpha be any number between 0 and 1. Then the 100, 1 minus alphth percentile is given by x sub alpha. So as an example, if I wanted the 88th percentile, that would be given by x sub 0.12. Since 88, the opposite percent of the 88, it would be 12%, and then 12% is a decimal, x sub 0.12. And the probability of x sub alpha is equal to the probability that x is less than or equal to x sub alpha, so 1 minus alpha. What this tells us is if you're in the 88th percentile, then 88% of the population is at or below your level. So the percentile tells you what proportion is either at or below that particular level. Quartiles are three very particular percentiles. The first is the 50th percentile. In this case, alpha is equal to 0.5. This is the median and is denoted by mu tilde. Sometimes we'll write mu tilde sub x if we want to refer to which random variable we're discussing. For the 25th percentile, we have alpha equal to 0.75. This is the lower quartile and is denoted by Q1. Finally, we have the 75th percentile. In that case, alpha is equal to 0.25. This is the upper quartile and denoted by Q3. Let's suppose we have a given CDF and we want to determine the median. For a CDF, the median would be where the y value of the graph is 0.5. So in this case, approximately 3. So here, our median would be equal to about 3. Now suppose we have a PDF and we want to find the median. This is where if I shade the left-hand side of the graph, then the shaded area has an area of 0.5. So in this case, our median would once again be 3, since the shaded area to the left of 3 is 0.5 and to the right of 3 is 0.5. Let's suppose our random variable x has PDF given by f of x equal to e to the minus x for x greater than or equal to 0, and f of x equal to 0 for x less than 0. I want to find the median in the 95th percentile. Let's start with the median. In this case, we want the area under the curve to be 0.5, and this needs to go from 0, our starting point, to some value that we'll call b. And that's what we're trying to solve. This is the integral of e to the negative x dx, since probability is given by the area under the PDF curve. Well, this integral is negative e to the negative x, taken between 0 and b. So we have 0.5 is equal to negative e to the negative b minus negative e to the negative 0. Well, e to the 0 is 1, so this would be 1 minus e to the negative b. I can subtract 1 from both sides. Multiply both sides by negative 1. And then take the natural log. So then I have natural log of 0.5 is equal to negative b. So b would be equal to negative ln of 0.5, which would be approximately 0.693. So the median of this function is 0.693. Now let's work on the 95th percentile. In this case, we want the area from 0 to an unknown value of e to the negative x dx to be equal to 0.95 since we want the 95th percentile. Well, we integrate this to get minus e to the minus x between 0 and b. Evaluating gives me negative e to the negative b minus negative e to the negative 0. So we have 0.95 is equal to 1 minus e to the negative b. We can subtract 1 from both sides, multiply both sides by -1, and then we can take the natural log of both sides. We have the natural log of 0.05 is equal to -b, or negative ln of 0.05 is equal to b. So in this case, we get 2.996 to be the approximate value of b, so our 95th percentile occurs at approximately 2.996. Next, let's consider the random variable given by the uniform distribution on a to b. I want to find the median in the 90th percentile. In this case, our PDF is given by f of x is equal to 1 over b minus a, if x is between a and b, and 0 otherwise. So for the median, we need 0.5 to be equal to the integral. Our interval starts at a. We don't know where it ends. I'm going to use a lowercase b here. Of 1 over b minus a dx. So if we integrate this, we get x over b minus a, taken between lowercase b and capital A. So we have 0.5 is equal to b over b minus a, minus capital A over b minus a. This gives me 0.5 is equal to little b minus a over b minus a. We can multiply both sides by the denominator, and then add a. So we end up with 0.5b minus 0.5a when I distribute this out, and then I want to add an a. So the median is given by 0.5b plus 0.5a, or 1/2 a plus b. So it is exactly the midpoint of this interval a to b. Now let's do the 90th percentile. So this time we need 0.9 to be equal to the integral from a to little b of 1 over b minus a dx. In other words, 0.9 is equal to x over b minus a, taken between a and lowercase b. So 0.9 is equal to little b over b minus a, minus a over b minus a. That gives us 0.9 is equal to little b minus a over big B minus a. We multiply both sides by the denominator. And then to solve for lowercase b, we need to add a to both sides. So if I distribute out the left-hand side, I have 0.9b minus 0.9a. I then need to add a to both sides. So I get 0.9b plus 0.1a. So in other words, the 90th percentile occurs at 1/10 a plus 9/10 b. So that would be our 90th percentile.